Okay, so last time we went over a ton of stuff. We talked about what's a primitive versus a reference type. And so remember, a primitive is those really simple types. There's 8 of them, and they store the data, the value directly, and it's fairly quick. Any other type of variable is a reference type, where it stores an address, so not the value directly, but an address for where it lives in memory. And so it stores that address. Any other kind of data type is going to be a reference type. So anything that's not one of these 8 is a reference type. It's non-primitive. So we looked at an example of a smart house, which is we have some sort of property, we have some behaviors that we want our smart house to be able to do, like turn on the lights, turn the temperature down to 60 degrees, open the garage door, close the blinds, right? Different behaviors that we want this house to have. We also have properties that we use to help manage the behaviors. So here are the actual lights that we have. Here's the variables that store that information. The number of windows, where does it live? Stuff like that. So we've got properties and behavior. We defined this smart house in its own class. So that's its own file and code where all of this information goes. And so we had this smarthouse.java. Maybe we'll zoom out a little bit so we can see. Is that too small? Nope, great. And so we've got fields, which are here the properties that we want to, things that we want to keep track of. We've got the methods or the behaviors, like we want to be able to order toilet paper or close the garage door or turn off the lights. So fields and methods, properties, behaviors. And all of this goes in its own class. And we start with uppercase letter. That's a typo. But yeah, so the name of the class must match the name of the file. All right, we talked about that. And we also needed a constructor for our house. So once we have gotten all these ideas down, when it comes to actually having to use our house, so let's say we had a file called housedriver.java. And so now we want to actually, because when we write smarthouse.java, we're creating a type called smarthouse. We want to make a variable of that type. And so we need to do that with a constructor. And so that's another type of thing that goes into the class body. And so that's what this is, where we have some visibility, and then we have the name of the class, which exactly matches the name of the class here, which exactly matches the name of the file. And so the constructor is what allows us to actually build this variable to say, in general, I'm going to have a smart house. It's going to have an address to, I have a smart house at 123 Main Street. It's the same difference as I have parameters for a function or a method versus when I actually use the method in practice. There's a difference between the idea and the execution. And so to go from idea to execution, we need a constructor in the class. And so we wrote a main method, but we wrote it in a separate class, which is good for modularity to kind of separate different things into different files. So we have everything to do with our smart house in one class, and then everything to do with testing in another class. So that is why we put our main method in the house driver class. So they're separate. Then we talked about how we actually call the constructor. So the declaring part on the left-hand side of the equal sign That's similar to before, where now just the type name starts with an uppercase letter because that's the convention for reference types. Reference types being anything other than a primitive. We've got our type name, we've got our variable name, and then the right-hand side is instantiating, where we are creating this object in memory. So we need the keyword new, then we need to repeat the type name, add parentheses, and then anything that goes into the constructor, anything that's an argument for the constructor goes inside the parentheses. So over here for our constructor, we had parameters of an address string. And then in practice, we said, here's the argument, 123 Main Street. Then we tested out operations of, we saw that equals equals works. It tests whether the objects are equal. And then generally these three work, and these guys, the typical arithmetic operators, don't. Because I don't know what it means to subtract two houses. We have to write more code. We have to define more things in order to say what actually happens when we do that. And so if we tried to do it, so let's see, I think I deleted that room, that one. So if we tried to do my house minus my house 2, then it gives us an error saying the operator is undefined. We haven't defined what it means to use the subtraction operator. We talked about objects, where an object is an instance of a non-primitive type. So non-primitive type being anything other than a number or Boolean or character. And an object is just an instance of that, or a concrete example. It's the difference between having 123 Main Street, my house, versus just the idea of the house. Then we talked about how to actually use any of our methods. So like, here's where we ordered toilet paper, where we have the variable name, a dot, the period, and then the name of the method, and then parentheses with any arguments. So this is called a dot operation, where we have the variable name dot method name. We looked at printing, where if we print my house, originally it just printed some combination of letters and numbers. But once we define a special method to string, then we say the house is located at this address. And then when we run that, here I will comment this line out so that we can actually run it. Then we get the house is located at 123 Main Street. So that's toString. Talked a little bit about garbage collector and scope, and now we've caught up. Any questions before we move forward? Great. Okay, so my plan is we're going to talk about arrays a little bit. We're going to talk about strings a little bit. And then if we finish by 2:15, 2:20, we'll go into lab 2. So when we remember arrays, these are linear structures, right? So we've got this box. So we had an example of like a box of candy, or we could have an array of numbers where each thing goes in each spot. It's a linear structure. We start counting it at 0. So it's indexed starting at 0. So down here is a little 0. That's spot 1, that's spot 2, spot 3, up until spot 9. And so there's 10 spots in our array here, but we just start counting at 0, so it goes 0 through 9. Only one type of variable. I'm going to change it per array. Only one type of variable is allowed. You can't mix and match like you could with Python. And you can't change the size once you create it. So once you have an array of 10 things, you can't add an 11th thing there. There's only 10 spots. So that's a problem. So if we have our box of candy and it goes up to Twix, and let's say we want to add candy corn to our box of candy, we're not allowed to like shove candy corn next to the Twix. We can't do that. We could take out, like if we wanted to take out York and put candy corn in there instead, that could be allowed. But what if we want to keep that? So we can't change the size once we create it. So our solution to this is a process called re-allocation, which is where we're going to make a bigger box and then transfer everything over. And so I've got this to kind of demonstrate how that works. So we've got our original box of candy here. We've got our new item that we want to add. So the first thing we need to do is we need to make the array a new array, and that's bigger than the one that we have. So since in this case, we know that we only want to add one additional piece of candy, so we make a box with 11 spots in it instead of 10. If we don't know how big we want our future box to be, typically the strategy is to make it like double the size and then copy everything over and hope that that's good enough until next time we run into this problem. But in this case, we know the exact size that we need, and so we'll just add one more box onto the end there. So this is one array in memory. This is a completely separate array, a new one. And so the idea is we go through our old box and we copy everything over. So for all of our Rolos and our M&Ms, we just take it from the old box, copy it over to the new box until we reach the end, at which point we add our candy corn into that last spot. Make sense so far? Make a bigger box, copy everything over, add any of the new stuff. And then we've got our new array. And so then what's typically done is you return the new one and reassign it to the old one so that you don't have to worry about the old one anymore. All you have to worry about is the new one. So the steps are, we make a new array, think about how big the size should be, depending on what the situation is, copy all the old things over, and then work with the new thing. Let's see that in action. So I'm going to make a new class. Oh. Is that okay? I just had a problem where it didn't fill in. Here's where it lives. And so if I go and select one of the packages where it lives, then and then try again, it autofills that information for me. Let's see, re-allocation test, and I'll include a main. So let's say I'll just start with integers. And we've got an array of 5 things. And then I want to add 6 to it. Unlike in Python, I could just say something like arr1.append 6. That doesn't fly here. So array's size is static. We cannot change it. So that's why we have to do reallocation in the first place. Secretly, Python is doing this under the hood. So when we call append on a Python list, it's doing what we're about to do. It just kind of hides it from you and doesn't tell you that it's doing it. So, so if I've got 5 things, maybe I want my new size to be 6. If I were adding more than one thing, I would want my new size to be that plus whatever. I may not want to hard code 6 as the size for my array. I may want to use the property belonging to arrays called dot length. And so then I just have a for loop to say start at the beginning, continue until I've reached the end of array 1 and add 1 each time. And then I just need to copy things over. In order to do that, I need something to copy them to. So I've got my old box and I'm all set up to copy things, but I need my new box set up. So my new array, arr2, is equal to new int. And so now I just want to allocate. And in here is where I need to say how big I want it to be. So let's copy that since I know how big I want it to be. And so that just says however long array 1 is, add 1, and that's my new size. Then what should I do in this spot? How do I copy things over? It'll be ARR. So remember, assignment works from right to left. So ARR something equals ARR something. So we want to copy from what? Yeah. Exactly. So yeah, so we go through everything in array 1 and we copy whatever is at the spot that we're at, and we copy it over to array 2. Do we want to go through array 2 dot length and then just at the end say something like error 2 at I is equal to, I don't know, 6 or something? No? Yeah. So this is where we would get into something like index out of bounds error, because if we go through array 2 dot length, let's say that's not, is this gonna work? Hold on. Okay, there's 2 things wrong with it. Let's test it. All right, the first error we get is says index out of bounds for length 5. But I know that there's multiple errors here. And so I want to know where did that happen? And so you can see that the first line here says, here's the exception. The second line here says it's at, this is the package, this is the file name, this is the function, Re-Allocation test.java, that's the file, and then :15. That 15 is a line number. So if I click on that, it'll select, here's the line I have a problem with. And so the issue here is that we've tried to access index 5 when it doesn't allow that because we start counting at 0. So in this case, we do need to have it go through array 1. And is this line going to give us, will this line work? No, because it's the same problem. So we could do 5, or we could do array 2 dot length equals, or length is the same problem. Length minus 1 will be our solution. So once we do that, we run it, nothing happens. Did we do something wrong? No. Why did nothing happen? Yeah, we didn't print anything. So stuff happened, but we just didn't tell the console about it. So in this case, we're all good. All right, so that's reallocation. Any questions on that? Great. Let's talk about strings. So remember when we talk about how chars are different from strings, where char is a character, it's a primitive type, it's only one character, and we define it with single quotes on either side. Strings is basically just a bunch of characters mashed together. Strings are a reference type, so they're not primitive. They are immutable. We'll talk about all of these. We can concatenate, we can push them together, we can find what's the length of a string, what character is at some point in a string. We can get a substring, so take out only some part of the string and then roll with that. We can compare strings and we can parse them into numbers. So strings are a reference type. They're a sequence of characters. So each spot in a string, so this is the letters A through K, each spot in a string is just an individual character. They're immutable, which means once we create it, we can't modify it. So even though they're a sequence, we can't just like swap one of the letters out. We have to create a whole new string with that letter swapped. So we can reassign string variables or replace them with new information if we need to. So I've got an activity of make a string equal something and then make it equal something else. So what that's going to look like is make something there, and then S1 is now equal to, I just want to type dots, commas it is. So make it equal to something and then something else. So do that for a second. Yeah. Okay, we're able to do that. Or we can say hello 1 2 3 and then hello 1 2 3 4. So we can reassign the string variable. We can also concatenate two strings. So we've done this with printing already, where if I have one string and then I say plus another string, then it smushes them together, doesn't add any spaces, and then we've got our result string. So let's do this in print. So if I print with a bunch of spaces, but then no space between these two hellos. If I run that, then the hello, the plus operator concatenates the two strings, which just smushes them together. So the plus operator does work on strings because the person who wrote the string class in Java defined what it means to be able to use plus on these objects. You can also do this with plus equals if you want to do it quickly. So that works. So plus equals does concatenation on the right-hand side and then assigns it to the variable on the left-hand side. To find the length of a string, we use dot length. So let's print s1 dot length. So if I start typing, so if I type the variable name and then I do dot, then I start typing length, Eclipse guesses what I'm trying to type. And so at this point, I could finish typing manually, or I can just press enter, and then it does that. Notice the difference between this dot length and that dot length. What's the difference? One of them has parentheses. Yeah. So arrays are a little bit different, where the length is a property that belongs to an array. For a string, it's a method that just returns the value of that property. So an autofill will help you as you get started with this, where you says you're trying to find the length of a string, you need parentheses. And so if you get to a point where you delete the parentheses, then it says, I don't know what that is. And so that tells you, oh, maybe I should try adding parentheses here. And when you do that, then the error goes away. Ah, I keep going between the wrong ones. So let's say we're looking at a string and we want to be able to find what's a specific character. So we can do that with the char at method. So now that we know what methods are, they're behaviors that belong to a type. So we can find, so let's get this one character. So since it's just a sequence of characters, we start counting at 0. So H is 0, E is 1, L is 2 and 3, O is 4, 1 is at index 5 in our string. And so we can print, let's do some concatenation here. So the 5th character is S1 dot, oh look, it's the first one. I think they're alphabetized, so that's handy. And so char at is selected. I could click on it, or I can just press enter. I'll press enter. And it's looking, and now it asks for an index. So I want to know what's the 5th character, the 5th indexed character in this string. So I do that, and then I can click away, save it, and run it. And I'm expecting to get 1. Hooray, we did it. So just like with arrays, we start counting the index at 0. So for a string, we're looking at this string, H is index 0, E is index 1, and so on until we get to 1, which is index 5. And the way we get that specific character is with the dot char at method. So it's great to get an individual character, but if we want, like, if I have a string saying my name is Sarah, and I want to get just my name from that, I can use a substring. Or I could use char at repeatedly, but that sounds tedious. And so for substring, it's like, do you remember like slices in Python where you can have the brackets and say start from here, end before here? We do that with substring. It's just a method. So we call our variable dot substring parentheses, and then our arguments are where do we want to start and where do we want to end. And so it ends 1 minus wherever you give it. So let's say A, B, C, D, E, F, G. That's the first 7 letters of the alphabet. And let's print the alphabet dot substring. And so if I type sub, then let's see. So there's a few options that pop up. So I've got substring just with the begin index. That's equivalent to doing something like if I have the string of, let's say, like 2 on. So I can give a number and then have a colon, and that just gives us a start index. I can also have 2 through 4, say, and so start at 2, take 3 as well, and then stop before 4. So 4 would not be included. And so the same kind of idea holds here. So we've got the begin index, which just tells us where do we start, and then it'll go to the end for us. We've got begin index and end index, which does start at begin and end one before end. And then subsequence, which is something different. So we want the second one. And so let's say we want to have B, C, D, E. So A is 0, B is 1. So we want to start at 1. And then we want to end. So G is 6 and F is 5, I believe. And so ideally that should give us A, B, C, D, E. Let's test it. Or B, C, D, E. My bad. So that works. And so we can play around with, like, if we want to stop before 7, that 7 is the very end of the string. It's the length of the string. And so it'll give us 2 through 6. If we want to go to 4, it'll give us 1, 2, and 3. B, C, and D. So we can play around with the numbers. So the key here is to remember that we start counting at 0, and that this second argument it'll go to 1 minus whatever you give it. All right. We can think about what does it mean to be for a string to be less than another or greater than another? Equal to, I feel like, should be fairly self-explanatory, right? So if 2 strings have the same letters, then I would say they're equal. So for example, let's test, is hello the same thing as hello? Thumbs up, thumbs down. Do we think this should be true? I agree. And that's true. What about hello and capital H hello? That's false. Why is it false? Yeah. Yeah, the H is different. One's capital, one's lowercase. Okay, so we can't naturally do greater than or less than. So let's talk about that. So we may want to consider, like, if we're working with strings, there is an ordering that we've imposed on strings in real life, right? There's a dictionary. So we can say that an aardvark comes before boat, comes before camera, right? If you look in the dictionary, there's an order to those things. And so to test whether they're equal, you can use either the equals, or you could use dot equals. For strings, they do the same thing. For other kinds of objects, they will not do the same thing. So like for houses, we'll talk about this in a bit as well. Calling equals on a house is not going to give you the same thing. Let's just test that really quick so you don't have to believe me. So let's say we've got my house is 123 Main Street, and let's say I'll call it my copy equals new smart house 123 Main Street. Nope, I have to call it STREET. So they've got the same data. The same string was passed as an argument to the constructor. Do we expect this to be true? I think it should, right? They've got the same information. No, it's false. Anybody have any guesses why? So what's happening here is so equals, unless you specify, here's what I want equals to mean for my type. Tests only the equality of the memory location. So it's asking, does my house and my copy live at the same spot in memory? And because I've said my house is a new smart house and it's assigned a spot in memory over here, and then down here we said my copy is a new smart house and it assigns a memory spot over here. They don't live at the same places, therefore they're not equal, even though all the data is the same. To fix that, we'll need to define a dot equals method in smart house, which I'm not going to do right now, but that's how we fix something like this. Note if we did something like my copy equals my house, where we assign the object to be equal to my copy, now this is going to give us true, because now they both reference the same spot in memory. So when they reference the same spot in memory, then it's true. Anyway, that's my sidetrack. For strings, they have decided that, so even though hello and hello probably occupy different spots in memory, the writers of the string class decided that we want to be able to use equals to test for equality. So that's why this works. So they were kind to us. You could also do this with, copy this line. You could also do this with dot equals. And we should get true both ways. Okay. I'll skip over compare to for now. That's one way that we test ordering. The main idea is that if we compare one thing to something else, if it's going to give us a number, if that number is 0, then they're the same. If it's less than 0, then the thing we called the dot operation on comes first. If it's greater than 0, it's the other way around. the ordering that it tests for this is Unicode ordering. So in Unicode, capital letters come before lowercase letters. So let me see if I can pull up emojis. Nope. Okay. I'll pull it up later. All right. So I think this is the trying my best. So let's say we want to, if we have a sentence, and do you remember like diagramming sentences in grade school where you break it into the different parts of speech? Where you break it into a noun phrase or a verb phrase, and then the noun phrase breaks into an article and the noun. This is parsing. So it's splitting some input into its parts. And so let's say we have a number as a string, so like 3.14, and we want to be able to use it as an actual number. Like it looks like a number, so why can't I add with it? In order to do that, we need to parse it. So there's functions that do this for us, where it takes this number and it transforms it into an actual number we can work with. And so something you need to know for the lab is you can say this, have this primitive type. So like double pi, pi is the name of this number. And then we can have, then to actually do the parsing, we need capital D double dot parse double, spelled like that. So the capital D here matters. And then we just give it, here's the string. Here's the string that I'm really sure is a number. So we'll give it 3.14. And this also works with something like if we've got an integer stored as a string or a Boolean variable stored as a string. We have to be sure that that string actually is that type, otherwise it'll crash, but we can do it that way. All right, so the last thing you'll need to know for the lab is a for each loop, which is, let's say for every mile on our road trip, the kids in the car get some candy. And so first we're going to distribute Rolos, then we'll distribute M&Ms, and so on. And so in Python, remember there's two kinds of for loops in Python. One of which where you have for I in range, however many spots our bag of candy has. But the other is this sort of for each loop, where you say for each candy in my bag, then print you get a candy. And so this kind of, it does the work for you of going through the range, where now you get to reference each item in the bag with its own variable. So for Java, we can do the same thing. First, we need to specify what sort of type is in the collection. So if we have an array of integers, we need to say this thing is going to be an integer. And then we need to give the item, the individual item, a name. And then we need to say, what's the name of our collection? So what are we working through here? So for an array, so let's say, let's go through array 2. So we have the for loop, for parentheses, and then on the left-hand side, we say, here's the item. I'm going to name it item. It is of type int, and I'm going through array 2. This is equivalent to or item in ARR2 in Python. We just have to specify here's what type it is. And there's the additional syntax of we need the colon. Let's just print here's the item. So I would expect to get 1, 2, 3, 4, 5, 6 printed to the console. And there we go. So the right-hand side is the collection. The left-hand side is the name of the variable and the type. For strings, if we want to do this, we need to be able, so if we want to go through the characters in the string, so let's say for char C in our string alphabet, we can't just do this because alphabet isn't a list of chars, it's a string. So we need to add an additional step to say alphabet dot to char array, where we can say, okay, I'm going to convert you to a char array, and we'll just print all those letters, and then it prints A, B, C, D, E, F, G. So we just have to convert it to a char array first. We could, if we wanted to not go through all the characters, but instead we wanted to go through each word. So let's say I had hello, my name is Sarah, and I want to print each word. String word in S. Then I need to use dot split. And since I want to split by words, I need to say split at the space. So when I reach a space, that's a separate word. And so when I do that, then I can print each word. And then it's going to give me my sentence, each word on one line. So these two steps are super important for lab 2. Any questions on those? So the difference between splitting to characters and splitting to words. All right. So we're going to have maybe half an hour, 40 minutes to work on the lab. The last problem on the lab is a little bit complicated. So I'll assign it to you today and I'll have you be in your groups. But I'll extend the due date for Thursday. So if you don't finish it today, you've got time outside of class to exchange numbers with your partner, meet outside of class and work on it so that you can submit it by Thursday at midnight. That sound good? Great. Let's go over how to clone the lab again. So we'll get to lists next time. So we're down here in lab 2, arrays and strings. And if I click on that link, it brings me to this page. Here are all the instructions, same format as last time. So this is a whole Java project. So once I put you in your groups, I'll copy this link. I'll go over here to Eclipse. I'll switch perspectives to the Java perspective. Now I have to clone the lab. So these are the instructions are the same as last time. So we clone a Git repository. That's this guy, the cloud with the green arrow on it. Clone URI, double click. This will autofill the link in. We can skip past this page. And then here's where we need to say, and then Sarah R and my partner's last initials. I will say that this part, so the first lab, I think we're kind of lenient. The first couple labs were a little bit lenient on the name scheming. So just make sure that you do this going forward, because otherwise we will start to kind of dock points for that. Partly because naming it in this manner makes grading a ton easier. So that way when we unzip your project, then we're not like, wait, whose is this? So if your name is in the project name, it makes grading a lot easier. Okay, so and once we do that, you would click finish, and then that loads and you go back to the Java perspective. All right, so I will stop recording, put you in your groups, and we're off to the races.